Number 15. Mass airflow sensor. Your engine is basically an air-breathing fuel furnace, and it has one job: burn gas efficiently. Too much fuel, you're hemorrhaging money at the pump. Too little, and your car drives like it's suffocating. The mass airflow sensor sits between the air filter and throttle body, weighing every molecule of air entering the engine so the computer can match it with the exact amount of fuel. Early systems used a mechanical flap that got pushed by incoming air. Clunky, unreliable, and it wore out faster than your patience in traffic. Then Bosch dropped the Hotwire MAF around 1985. No moving parts, just a heated wire that gets cooled by airflow, and the computer measures how much current it takes to keep that wire hot. Brilliant. Here's where it gets stupid. See that mesh screen on your MAF? It's not measuring anything. It just smooths airflow. And if you're running one of those oiled performance air filters because you wanted 5 extra horsepower, congratulations, you just murdered your MAF. That oil coats the sensor, trashes the readings, and confuses your ECU into making catastrophically bad decisions. GM even issued a bulletin warning that contaminated MAP sensors were causing transmissions to shift like they were having a seizure. Number 14. Manifold absolute pressure sensor. Some engineers looked at the MAF and said, what if we just skip measuring the air entirely and calculate it from vacuum pressure instead? Enter the MAP sensor, bolted to the intake manifold, reading the pressure inside. When you floor it, vacuum drops, pressure spikes, and the MAP screams to the ECU, send fuel now. When you're coasting, vacuum is high and the computer backs off. Simple, elegant. And for turbocharged cars, it's absolutely critical because it measures boost pressure. Some manufacturers use both MAF and MAP, paranoid accountants double-checking the math. Others go full speed density mode, ditching the MAF entirely and calculating airflow from RPM, throttle position, and manifold pressure. It works, but if one sensor lies, the whole system implodes. Number 13. Oxygen sensor. Before oxygen sensors, cars just guessed how much fuel to burn. Spoiler, they guessed wrong. Constantly, engines either choked on too much fuel or starved on too little, spewing pollution like a coal-fired power plant. The oxygen sensor changed everything. Screwed into your exhaust pipe, it sniffs the gases coming out and measures leftover oxygen. Too much oxygen? Running lean. Too little? Running rich. The ECU uses this feedback to adjust fuel delivery in real time, chasing the perfect ratio. Bosch invented the Lambda sensor in the early 1970s, and Volvo, the Swedish safety obsessives who gave us seatbelts, installed the first one on a production car. The 1976 Volvo 240, specifically California-bound models, got the world's first oxygen sensor paired with a catalytic converter. Tom Quinn, chairman of California's Air Resources Board, called it the most significant breakthrough ever made in vehicle exhaust emissions control. He wasn't exaggerating. It eliminated over 90% of hydrocarbons, carbon monoxide, and nitrogen oxides. By 1977, Ford panicked and ordered over 3 million Lambda sensors per year from Bosch. And when OBDI regulations hit in 1998, every car suddenly needed 2 oxygen sensors, one before the CAT and one after, to make sure the converter wasn't slacking off. The market doubled overnight. Number 12. Engine coolant temperature sensor. Your engine needs to know if it's freezing or fully warmed up, because the fuel mixture changes depending on temperature. Cold engines need extra fuel, like the old carburetor choke. Hot engines don't. The coolant temp sensor, stuck directly in the engine block bathing in coolant, tells the ECU exactly what's happening. When it fails, your life becomes hell. Dead battery on a winter morning because the car won't start? Bad coolant sensor. The ECU thinks the engine's already warm and refuses to add the extra fuel needed to fire up a cold engine. Or worse, your car overheats on the highway because the cooling fans never turn on, cooking your engine into scrap metal, all because a $5 sensor lied. Number 11. Intake air temperature sensor. Cold air is denser than hot air. More oxygen molecules per cubic foot means more fuel can burn, which means more power. The IAT sensor measures incoming air temperature so the ECU can adjust the fuel mixture. Cold morning, your car feels strong. Scorching summer day, it feels sluggish. Same engine, different air density. That's the IAT doing its job. Number 10. Throttle position sensor. The gas pedal used to connect directly to the throttle with a cable. Simple, mechanical, no drama. but the ECU had no idea how far you'd press the pedal unless it had a sensor watching. The throttle position sensor tracks the exact angle of the throttle valve. Idling, 0%. Cruising, somewhere in the middle. Wide open throttle? You're asking for everything. Modern drive-by-wire systems killed the cable entirely. Now there are two TPS sensors for redundancy. If they disagree on throttle position, the car assumes something's catastrophically wrong and goes into limp mode, neutering your engine to about 20% power. It's the automotive equivalent of your computer blue screening because one sensor told a lie. Number 9. Camshaft position sensor. The camshaft opens and closes your valves. The ECU needs to know exactly where it is to fire the fuel injectors at the precise moment the intake valve opens. That's sequential fuel injection, and it's the difference between smooth power and sputtering inefficiency. Without the cam sensor, the engine might still run, but it falls back to batch fire mode, where multiple injectors fire at once like a shotgun blast instead of a sniper rifle. In some cars, if the cam sensor dies, the engine won't start at all because the computer can't figure out which cylinder is ready to fire. Number 8. Crankshaft position sensor. This is the one sensor you absolutely cannot live without. The crankshaft sensor watches the engine spin, counting teeth on a toothed wheel to calculate RPM and crankshaft position. It controls ignition timing, telling the spark plugs exactly when to fire. If this sensor dies, the ECU immediately cuts fuel and spark because it has no idea if the engine is even turning. Your car dies instantly. No limp mode, no warning, just dead on the side of the road. And the worst part, it usually fails without warning, often when the engine's hot, leaving you stranded in traffic wondering what you did to deserve this. Number 7. Knock sensor. Detonation is the sound of your engine trying to commit suicide. It happens when the air-fuel mixture explodes prematurely before the spark plug fires, creating a shock wave that can punch holes in pistons and destroy bearings in seconds. The knock sensor is a tiny microphone bolted to the engine block, listening for that telltale rattle. When it hears detonation, it screams at the ECU, which immediately retards ignition timing to stop the knocking before your engine turns into expensive scrap metal. Saab made this technology famous in the early 1980s with their APC system, Automatic Performance Control, in the 900 Turbo. It let the engine safely run on varying fuel grades and boost levels by constantly listening for knock and adjusting on the fly. Today, knock sensors are standard on every engine, especially turbocharged ones. They're the silent guardian standing between aggressive tuning and catastrophic failure. Number 6. Oil pressure sensor. Oil pressure keeps a thin film of oil between metal parts spinning at thousands of RPM. If that pressure drops, the film disappears and metal grinds on metal. Bearings, camshafts, crankshafts, all destroyed within seconds. The oil pressure sensor monitors this and screams at you via a dashboard light if pressure drops below critical levels. When that light comes on, you stop. Immediately. Not in 5 minutes. Not at the next exit. Now. Because every second you keep driving is another second closer to needing a new engine. Number 5. Fuel rail pressure sensor. Old port fuel injection systems ran at around 50 psi. Respectable. Then came gasoline direct injection, where fuel gets blasted directly into the combustion chamber at over 2,000 psi. Diesel common rail systems, nearly 30,000 psi. At those insane pressures, fuel atomizes into a fine mist that burns cleaner and more efficiently. But the ECU needs to know the exact pressure to calculate injector pulse width correctly. Too much pressure, you risk damaging components. Too little, and the fuel won't atomize, killing performance and spiking emissions. The fuel rail pressure sensor monitors this constantly, keeping everything from exploding. Number 4. Wheel speed sensor. Before ADS, slamming on the brakes locked the wheels, and you just slid in a straight line, praying physics would be kind. With ABS, the car pulses the brakes dozens of times per second, keeping the wheels on the edge of lockup so you can steer while braking. But ABS needs to know the exact rotational speed of every wheel. That's the wheel speed sensor's job. If one wheel suddenly slows down faster than the others, the ABS computer knows it's locking up and pulses the brake to release it. Mercedes-Benz and Bosch debuted the first electronic four-wheel ABS system on the W116 S-Class in August 1978. It cost over 2,200 Deutschmarks, basically a small fortune, but it worked. By 1980, Mercedes offered ABS across the entire lineup. By 1992, it was standard equipment. Today, wheel speed sensors don't just power ABS. They also run traction control, stability control, speedometers, and cruise control. One sensor, a dozen critical jobs. Number 3. Steering angle sensor, hidden inside your steering column. The steering angle sensor tracks how far you've turned the wheel and how fast. It's the brain behind electronic stability control. Here's how it works. The sensor tells the computer where you want to go based on steering input. Meanwhile, other sensors tell the computer where the car is actually going. If those don't match, if you're steering left but the car's sliding straight, ESC slams individual brakes to yank the car back into line. It's the automotive equivalent of a guardian angel grabbing the wheel and saying, "Nope, not today." And it saved countless lives by preventing rollovers and spinouts that would have been catastrophic. Number 2. Tire pressure monitoring sensor. TPMS exists because Firestone tires kept failing on Ford Explorers in the late 1990s, causing rollovers that killed over 100 people. Congress panicked and passed the Trade Act in 2000, mandating tire pressure monitoring on every passenger vehicle sold in the U.S. by September 2007. The system uses a battery-powered radio transmitter inside each tire's valve stem, measuring air pressure and wirelessly sending data to a receiver in the car. If pressure drops too low, a warning light comes on, hopefully before you have a blowout at 70 miles per hour. But here's the twist. The first production car with TPMS wasn't some economy sedan trying to meet regulations. It was the Porsche 959 in 1986, the twin-turbocharged, all-wheel drive 200-plus miles per German supercar. Porsche knew a tire failure at 200 miles per hour would be catastrophic, so they built sensors into the hollow spoke wheels. Clunky compared to modern systems, but it worked. Porsche later used similar tech on the 928 from 1990 to 1994, before switching to valve stem-based sensors in 2004. Number 1. Fuel tank pressure sensor. Your gas tank is part of the evaporative emission control system, designed to keep raw fuel vapors from escaping into the atmosphere. The fuel tank pressure sensor is the enforcer, making sure the system stays sealed. Mounted on top of the fuel tank, this sensor measures pressure inside the tank. Periodically, the ECU closes all the vents and monitors the sensor. If pressure holds steady, the system is sealed. If it drops, there's a leak. Loose gas cap, cracked hose, failed purge valve, doesn't matter. The sensor detects it, triggers a check engine light, and stores a diagnostic code. It's not glamorous, but it's the reason modern cars meet emission standards without leaking fuel vapors every time you park. Small, unglamorous, essential. And we're all breathing cleaner air because of it. Before we wrap up, make sure to leave a like and share your thoughts on the most interesting sensor we've mentioned so far. So there you have it. 15 sensors working around the clock, feeding data to your ECU, adjusting fuel, timing, braking, and emissions in real time. Modern cars are rolling computers, and these sensors are the eyes and ears keeping everything from exploding. We hope you enjoyed this video. Here's another one you'll love. As always, thanks for watching.